Hey there. We're about to dive into the invisible forces that, and I mean this, literally shape our entire world. From something as simple as walking across the room to the grand dance of the planets in space. It all boils down to two key ideas: friction and gravity. So let's get right into it. So, a sliding book and a falling apple, what could they possibly have in common? Well, it might sound like a bit of a riddle, right? But the answer really gets to the core of what we're talking about today. In both cases, there's a force at play. The book, it's being slowed down by the surface it's sliding on. The apple, it's being pulled down by the entire planet. Two very different interactions, but both driven by forces. Okay, so before we can really unpack friction and gravity, we've got to make sure we're on the same page. What even is a force? It's actually a super simple idea, but it's the key to understanding, well, pretty much every interaction you see. And there it is, a push or a pull. That's it. Every single time something speeds up, slows down, or just changes direction, you can bet a force is responsible. You can think of it as the engine driving all motion in the universe. Okay, with that foundation laid, let's tackle our first big force. All right, first up is friction. And I just love this description for it. The sticky force. Doesn't that just perfectly capture the feeling? It's that resistance you feel when you're trying to shove a heavy box across the floor. It's the reason a ball you roll will eventually grind to a halt. So the key thing to remember about friction is this. It always works against the direction something is trying to move. It's a total force of opposition. And this is critical. It can only happen if two surfaces are actually touching, rubbing against each other. But here's the thing. It does more than just slow stuff down. I mean, have you ever rubbed your hands together on a cold day to warm them up? Of course you have. Well, that's friction in action, right there. You're literally converting the energy from that rubbing motion into heat. And it's that exact same process that explains why car brakes can get scorching hot, or why moving parts in any machine eventually wear down over time. And this whole idea about surfaces, it's just so intuitive, isn't it? You know it's way harder to drag something heavy across a shaggy carpet than it is across a polished wood floor. And that's because all those little microscopic bumps and ridges on rough surfaces, they kind of snag and catch on each other. That creates a ton more resistance than you'd get with smooth surfaces. So yeah, friction isn't just one single thing. It's got layers. Think about trying to push a super heavy couch. That first shove, just to get it unstuck, it's the absolute hardest part, right? Well, that's you fighting against static friction. But once it's actually sliding, it gets a little easier. You're still pushing against a force, but now it's a different kind. That's kinetic friction. And even that kinetic friction, the moving friction, it comes in a few different flavors. So let's quickly break down the three big ones you'll run into. First, you've got sliding friction. This is the classic, the one we all think of. It's just what happens when two solid surfaces slide right past each other. Like a hockey puck gliding on ice, or that book you just shoved across your desk. Next up is rolling friction, and this one's pretty fascinating. It's the reason why even a bowling ball on a perfectly flat lean will eventually stop. What's happening is that both the ball and the surface squish and deform just a tiny bit where they touch. That creates resistance. Now, it's usually way weaker than sliding friction, which, when you think about it, is exactly why inventing the wheel was such an incredible game changer for humanity. And finally, there's air friction. You've probably heard it called air resistance or drag. The air might seem totally empty, but it's actually full of tiny molecules. And when anything moves through it, it has to physically push all those molecules out of the way. For something like a big, open parachute, which is designed to catch as much air as possible, that force becomes absolutely massive and, of course, totally life-saving. Okay, so we've spent a good amount of time on the force that happens when things touch. Now, let's zoom out. I mean, way out. Let's talk about the force that doesn't need to touch anything at all. The one that works across the mind-boggling emptiness of space. Let's talk gravity. When it comes to gravity, there are really four key things that make it so special, and we're going to hit every one of them. It's an attracting force, it's universal, it's a non-contact force, and while it's the reason our feet are planted firmly on the ground. Okay, first thing, gravity attracts. Unlike friction, which is all about resisting and pushing back, gravity only ever does one thing. It pulls. It's always an attractive force. So the Earth pulls on the apple, which is why it falls down, obviously. But get this, and this is the really mind-bending part, the apple is also pulling back on the Earth with the exact same amount of force. Seriously, the only reason we don't see the Earth fly up to meet the apple is because, well, it's just so ridiculously massive in comparison. And that right there is the core of what we call the universal law of gravitation. It's not just about planets pulling on apples. It means that every object in the universe is pulling on every other object. So right now, you are gravitationally attracted to your screen, to the person in the next room, even to the stars in a galaxy millions of light years away. The pull is just so incredibly tiny that we only ever notice it when something really, really massive, like a whole planet, is involved. This brings us to our next point, which is where gravity starts to feel a little spooky. Unlike friction, which absolutely has to have surfaces touching, gravity works across empty space. It's a non-contact force. The Earth can literally reach out and pull a ball out of the air without any physical connection. Think about it. The sun holds onto the Earth from 93 million miles away, across a total vacuum. It's just a fundamental rule of how our universe is put together. So let's bring that huge cosmic idea right back down to Earth, literally. The reason you're sitting in your chair right now and not floating up to the ceiling? Gravity. The reason we have an atmosphere to breathe instead of it just drifting off into space? Yep, gravity again. It's this constant, invisible force that grounds us and anchors our entire reality. All right, so we've met our two main players, right? We've got friction, the sticky force, and we've got gravity, the universal pull. So now let's put them side by side and really nail down the huge difference between them. And this really just boils it all down perfectly. Friction is a contact force. It's hands-on. It needs surfaces to be physically rubbing against each other to work. Gravity, on the other hand, is a non-contact force. It's totally hands-off. It's a pull that can act across vast distances of empty space. And honestly, if you take away just one thing from all this, it's that difference. Contact versus non-contact. That's the whole ballgame. And look, getting this distinction isn't just for a science test, you know? It's absolutely fundamental to understanding why our world and our universe works the way it does. I mean, just think about the sheer scale we're talking about here. At one end, you have friction. You couldn't even take a single step without the friction between your shoes and the floor. But at the other end, you have gravity. The sun's gravity is what keeps our entire planet locked in orbit, giving us seasons, giving us life. They really are the invisible architects of everything we experience. So let's wrap this up with a little thought experiment. Imagine you had a big switch. You could turn off either friction or gravity for just one day. Which one would cause more chaos? Think about it. With no gravity, everything that isn't nailed down just floats off into space. But with no friction, nothing could ever stop moving. You couldn't even walk because your feet would just slip. It's a tough call, right? And it really makes you appreciate just how important these incredible invisible forces really are.